Hello everyone, welcome back to another banger video. Today we're going to be building a machine learning model to predict diabetes. We'll use a dataset of medical records, process it, build a random forest classifier, and evaluate its performance. Before we get into the video, if you guys want to see more machine learning videos like this, drop a like down below. It helps us out tremendously with the YouTube algorithm. With that out of the way, let's hop right into it. Alright, so the first thing we're going to need to do is load our dataset. The dataset for this project will be linked in the description. It's on Kaggle. You just go and download it and then upload it. So we'll use pandas, which is a library that allows for easy manipulation and analysis of our data. But before we import pandas, we need to actually upload our dataset. And if you're in Colab, an easy way to do this is to put this code right here. So this will prompt a little drop down like this where you can choose files and upload the dataset, which will be in the description. Alright, so now let's go ahead and import pandas and load our dataset. Right, let's print out head. Alright, so here we see the first 5 records of our diabetes dataset. Notice the columns. Each one is a feature like glucose level, blood pressure, which are crucial for predicting diabetes and using machine learning. Next, let's perform exploratory data analysis, or EDA. EDA helps us understand the basic statistics of the dataset, check for missing values, and visualize data distributions. EDA is important because it can reveal patterns, outliers, and basic hypotheses about the data. Let's go ahead and do that now. Alright, so here we used pandas to generate descriptive statistics which give us the mean, median, and range values. Then we use box plots for each feature against the outcome to see how different values affect the prediction. This is where we could start to make a hypothesis about what features are most important. And here are our box plots. Alright, so our next step is data preprocessing, and it's vital because the performance of machine learning models is heavily dependent on the quality of the data fed into them. We'll handle missing values, scale our features, and split the dataset into training and testing sets. Let's go ahead and do that now. Make sure the O here is capitalized. So, made an error here. Two typos. Alright, so here, the train test split function, which is right here, is used to divide our data so that the model has a fresh set of data to validate its predictions. Standard scalar is then applied to normalize our feature set, which can help improve the performance of our classifier. Now let's go ahead and build the random forest classifier. A random forest is an ensemble of a decision tree. It's typically trained with the bagging method. Using an ensemble method combines the predictions of several base estimators to improve generalizability and robustness over a single estimator. Alright, so let's go ahead and do that now. Alright, so we've just initialized a random forest classifier and trained it on our scaled training data. Training a model is the core of machine learning, where the algorithm learns the relationship between the features and the outcomes and then makes an informed decision. Alright, so finally, we must evaluate the model to understand its performance. Accuracy is the proportion of true results among the total number of cases examined. A confusion matrix is a table that is often used to describe the performance of a classification model. So let's go ahead and write the code for that now. Right. So here we just predicted the diabetes occurrences of our test set and calculated the model's accuracy, which is 72%. So it's not too accurate, but it'll get around 3 out of 4. We then printed the confusion matrix to show the true, positive, and negative rates, which are right here, as well as the false positive and the negative rates as well. Alright, so that's going to be it for this video. If you guys enjoyed or want to see more videos like this, drop a like down below, subscribe, and we'll catch you in the next one.